Okay, I want to let you guys in my head a little bit about how I think about math in general. Is I understand that there are verbal words that describe problems that go on in the world, and those verbal problems that we come up with in the world, we like to sometimes break them down into pictures. That's the geometric or graphical. Sometimes we break them down into symbols like so much money. We put it as a variable. We say uh, x, okay, or a or n. Those are symbolic representations, and we call that algebraic. And then finally, there's the numeric way that we can break things down, and that's like 2 plus 2, right? Um, so when we look at this understanding of transformations, we've kind of gone over the whole geometric representation. We've talked about the verbal, how things translate, rotate, and reflect, and dilate. But I want to also look at the algebraic because it is useful in some fields to be able to represent these in a symbolic form so that you can shorthand write exactly what it is that you're doing. So I have a little sheet here that summarizes it. And I know notation can be a hassle sometimes. It's one of the hardest things that I had to struggle with early on. But if we go through it a little bit slower and talk about it, what you have here is r sub x-axis. So we call that r sub x-axis. So when you see that little, call it a subscript below the letter, that represents where the line is getting reflected. So these are line reflections, and they have either a title or they have a line actually represented there. We're going to get into these a little bit later in the class, where you reflect across lines that are of this form, y equals something mx plus b. But right now we're just dealing with reflections across the x-axis and the y-axis, so that's how they're written down. And then they have some point that it is going to be reflected across. And then when it's reflected across the x-axis, you get a new point, and that new point is, in this case, is x negative y. So I just threw a big symbol at you. Now let's kind of describe what it means. Let's break it down. Okay, so we have our y-axis and our x-axis, and we have some point. So this point here is 3, 2. And if we were to reflect it across the x-axis, it would be an equal distance from the x-axis on the other side and pop up right there. Okay, so reflect x-axis, the point 3, negative 2, or 3, 2. So what point do we get? We get 3, negative 2, right? So the x coordinate did not change at all, and the y coordinate, if you do a ton of these, you would notice that every time you reflect it, you get the same x value, but the y value happens to change sign. So this new point was 3, negative 2. And if you did a lot, then you would see that every time you reflect across the x-axis, you get your starting point changes from whatever the x, y is into x, comma, negative y. Okay, so this is the notation that we're using to show that a reflection across the x-axis happens. Now, what are some other notations? If you reflect across the y-axis, your xy becomes negative xy. So what does that look like? If I took that same point, 3, 2, and I reflected across the y-axis, this 3 away from the y-axis now becomes 3 away on the other side, and that would be the point negative 3, 2. So you see a reflection across the y-axis of the point xy would be a change in sign on the x, so it would be negative x, comma, and no change in sign on the y. Okay. What other options do we have? Translations. So a translation, this is t sub h and k. T sub h comma k. Okay, so translation of h and k, and then what it results in is the x value increases by h, the y value increases by k. So it's just x plus h, y plus k. So what does that mean? Let's take that same point, 3 comma 2, and let's say we had a translation of, so translation of 4 comma 1 of 3 2. So what does that mean? We're going to go over 4 in the x direction, 1 2 3 4, up 1. So we translate by that vector is what we called it before. So 3 6 7. So this new point is 7 and 3. 7 3 is my new point. Now in general, if you do a lot of these, you would see that every time whatever number you have here and here gets added to the number that's here and here. So a symbolic way to write it is t sub h and k of xy looks like this. You take your x value, you add h to it. So we took 3 and we added 4 to it, right? And you take your y value and you add k. So I took my 2 and I added 1 to it. So I got y plus k. Okay. So what else? We have rotations. So these rotations, you just put a capital R and the number of degrees that it is being rotated through. So different rotations give you different points, right? That makes sense. So let's take an example. So let's say I started with this point over here. Negative 4, 3. And let's say I rotated that 90 degrees. So if this is my 0 degrees, 90 degrees would be to there. Okay, so if I take this point and I do a rigid rotation, I'm going to use this L as a guide. So it's going to rotate down to here. So my new point is 4 over and 3 up is now 4 down and 3 over. My new point is negative 3 in the x direction, negative 4 in the y. So my rotation of 90 degrees of the point negative 4, 3 came out negative 3, negative 4. Okay, so in general, rotations of 90 degrees of some point, you would see if you did a lot of these that it always ends up being that the x value and the y value get switched, and the sign changes on the x value. So or the original y value becomes the new x, but it changes sign. Okay, so this is the algebraic way to write that that transformation. Okay, and then the final one is dilation. So dilation is a capital D with a little sub k. So d sub k of the point xy becomes the new point, which is, it's going to be k times x, k times y. And this has to be directly from the origin. if you dilate about another point, if you dilate it about another point, it will give you a different layout, but we're just worried about this kind of algebraic notation right now. So if we dilate about the origin, the point 3, 2, and we want it to triple in size, so we'll do 3 times. So the new point would be, see, I'm going over 3 up 2, over 3 up 2, so this would be twice as big, but I want to go 3 times, so another 3 over up 2. Okay, so my new point would be 3, 6, 9 in the x direction, and 2, 4, 6 in the y. So the dilations in general, if it's any value, so it could be 1/2, it could be 2, it could be 4, any value of dilation about at the point x, y turns into whatever that number is times x, so kx, and whatever that number is times y, ky. Okay? So I hope that's not too confusing. This is just a way that mathematicians write this. So if you understand the principles, the notation doesn't come too hard. Okay? So just practice with the concepts, and once you have that down, then you can start worrying about getting the notation right. Okay?